Good evening. Great to see you all again here. Before we will start our meeting, I would like to say a few information about our upcoming event. And it's called Silesian AI, and you can guess that it's focused on artificial intelligence. The first of all, the project was created in cooperation with 3 different companies, and one of them is Istek Alsiglice, which one I'm representing here now. To be more precise, there will be 3 different events, and 2 of them are workshops. The first one will be guided by Skygate, and the second one by Groupon. The dates are placed on the slide. Moreover, in case of workshops, we are looking for 15 best local students from Silesia area. It could be, for example, from Silesian University of Technology. And this group will be connected with 15 international students, for example, from countries like Spain, Italy, Germany, Portugal, and of course other countries. Everything will be finished by 500 people's conference, which will take place on the Educational and Congress Center. And in the end, I would like to ask you about following our fan page, Skyhacks, because every crucial information and every important information will be placed there. And generally, that's all. So thank you for your time, and my voice going to Chris, CEO of Skygate.
Okay. So I won't take very long. I like to went to our meetup.com page when we host all these events, so you can subscribe and get notified so you won't miss any. And right now my voice goes to Marcin, who is MVP, Microsoft MVP, and he will start this meetup today. So give him a warm hand. And Marcin, I guess you might need some time to connect your computer, but then the voice will be yours. So 2 minutes for Marcin, but right now we can give him a warm hand, and let's kick this off.
Good evening. Thank you for having me here. And thank you, so I should welcome you to this talk about machine learning best practices. So, who of you is playing with this machine learning stuff right now? Okay. A good number. Who knows what Kaggle is? So, any Kaggle players? 1, 2, more. Great. Do you read manuals? You know, nowadays they are everywhere. If you buy a medicine, you will get a manual as well, yeah? I do. If everything works, you don't need them. But if nothing works, 10 minutes reading can save you a lot of trouble. Okay? So I'm Marcin Szeliga, machine learning practitioner. I've been working with Microsoft Data Platform for almost 20 years, or over 20 years right now. So I saw it growing. We started with databases, generally speaking. Now it's a lot of different machine learning services. And I'm not going to show you all those services, we will stay focused on this Kaggle competition. And I have also some time to write about it, this Microsoft Data Platform. I'm writing the last book right now, it's Practical Machine Learning. It should be published this year. Nevertheless, some sample code is already available on GitHub. So I will give you a link at the end of the session. Okay, and yeah, you will see my contact details one more time. Okay, last question, and we are ready to go. This data community PR. Do you heard about this? Nothing, not at all. Nobody. Yeah, that's a shame. So, so please, not right now, maybe after, type datacommunity.pl. You will find our website. It's a non-profit organization. We started over 10 years ago, and we are organizing meetings as well, something like this one, but not only meetings, also conferences. And the upcoming one is SQL Day in May, okay? But there are also free conferences called SQL Saturday. So nice place to, if you are interested in data platform, maybe it's good place to start. To build a predictive model, we need three things. Training examples. Can you see it? Training examples, learning algorithm, and loss function. By the way, I know that we have some time, extra time, so if you have any questions relevant to the topic we are discussing right now, don't wait, just raise your hand and we will manage, yeah? Because I don't want to lose you. So, three things. Training examples, learning algorithm, loss function. Seems easy. Did you try this infamous approach to machine learning? Everyone did. That's a hype phase. Okay? But think about what can go wrong if we try everything, mixing everything, till we get good enough results. Actually, we need one more thing to build those models. Good tools. And now the part about Microsoft technologies. So it's called Microsoft Machine Learning Server. Okay? Microsoft Machine Learning Server is Python and R enabled, which means it's 100% compatible with Python and R. Okay? However, some weaknesses of those languages were addressed. For example, moving computation to where your data lives can reduce training time from hours to seconds. Okay? With this machine learning, Microsoft Machine Learning Server, you will also get a rich set of scalable, state-of-the-art algorithms. They are packed in three libraries: RevoScale Pi, RevoScale R, and Microsoft ML. Finally, it gives you simple, secure, high-scale operationalization. And soon or later you will find that this kind of things are nice to have, because building a model is one part of the story. Using the model is completely different one, okay? So, this server is available for different platforms, Linux, Windows, Hadoop, etc. And here I will use a version integrated with SQL Server. As I said, I'm from databases. I spend a lot of time working with SQL Server, still like it. So, how many of you are Python developers? Okay, 20% maybe. R people. Does anybody heard about this language? Who is using it? Okay, nobody, almost. That's the reason why I choose R for this talk. To get you outside your comfort zone and help you focus on ideas, not the code, okay? So be with me. What's happened here? First, I'm switching computation context to local parallel, which means from now on, the script will run on my local machine, but multi-threaded. For R, it's actually a big deal. Train file was downloaded from Kaggle website and put into text data source. The data is not in memory yet. It will be loaded into memory in chunks, only when needed. Then SQL Server data source was defined and the data was moved to a table. That's the simplest invocation of Rx data step. All those functions from those libraries I mentioned, RevoScale Pi, RevoScale R, and Microsoft ML starts with Rx, okay? Easy to spot. So that's the simplest invocation of this function, which also allows you to transform data on the fly. Finally, this table was converted to column store index. Column store indexes are powered by Microsoft X Velocity technology, and it's blazing fast. It scales to billions of rows easily. So that's a baby example, small file, but exactly the same procedure, the same methodology will work for billions of rows. So, now we have data in a database, in a table. Let's build a model. And a glue that allows you to integrate SQL with Python and R is this SP execute external script store procedure. It does it by sending the query result to external language runtime and getting the results at back. Okay? So it's an R script, just 3 lines of code. First, I'm predicting survived based on all available input variables. What does it mean? In terms of variables, really, because I want to be sure that we are on the same page. What the task is. We are following this infamous, let's try everything, methodology. So we got the data, loaded it, found some variables, means columns. One was set its output variable or label, that one. So I'm saying, okay, give me value of this column predicted based on all those. Yeah? That's the learning formula. Hypothesis. Then, random forest model is trained. Easy, as I said. All default values were used. Just formula and dataset, trained dataset was specified, yeah? Nothing more. And this trained model was serialized and sent back to SQL Server, where it's stored in a table. Nice. So, this, actually, a person could only died or survived. I will explain this later. So, it's a binary classification. That's a binary classification. And the simplest metric for binary classifiers is accuracy. Accuracy is a ratio of number of correct predictions to total number of predictions. 99 something, 0.99 means what? Good, not good, fabulous. So this model built like this, 3 lines of code, made just a few mistakes on trained data and misclassified some survivors as victims. That's it. So let's start, now it's time to fetch the model from a table and use it for prediction. We are ready. Yeah? As I said, machine learning is easy. So, model was selected and sent to this external script. Now, where it was unserialized, and then I'm calling rxpredict function, but now I'm using test data set. Test data, yes?
Very quick question about selecting exact model. Is there some documentation or which model, sorry. Is there exact documentation or which model, actually the list of the model or the documentation from which we can select given model, or just have to like find it out somehow else?
Very good, very nice question, but you have to wait. Because right now we are going a little blindly, yeah? But that's very nice, and I will go through this. Now I'm just selecting model based on name. So I randomly choose random forest as a learning algorithm because it was very good for this talk, okay? I'm not saying that random forest is the best. There is no the best algorithm, actually. So we will go to this. Thank you. So now the model is deserialized, and I called rxpredict to predict survived, yes, no, based, but using test data. Test means there was no answer there. There was no survived in this data set. Okay, and so survived the prediction, and the passenger IDs are retrieved and written to CSV. Because, you know, to submit to Kaggle, you have to send them results in CSV. What do you think? Did we win? Like, with this. 99% something. Why not? Okay. So you were right. You were right. 62% of people died. Our true accuracy, so accuracy measured using test data, is 0.62, which means we reached random guessing accuracy. Nicely done. But there is more. Over 10,000 people submitted their results to this competition, and we are 8,000 something, which means 20% of submissions are even worse than random guessing. So that's the very reason for this talk. Black box approach leads to spending a lot of time and resources with no gain at all. So, instead of blindly applying machine learning algorithms to data piles, let's try a proven methodology. Cross-industry standard process for data mining is open standard developed in 1997. And so, at that time, machine learning was called data mining. And since then, CRISP-DM provides structured approach to machine learning projects. And it breaks the process into 6 major phases. You should start with business understanding, which means you should know what are you going to achieve from business perspective. Then there is data understanding, and to understand your data, you have to understand the problem. Plus, you have to describe variables and patterns. Third stage, data preparation. To assess and to improve data quality, you have to understand your data. So it's actually like this. Sorry. You cannot skip any of those stages. Then is modeling. You already did it. The fun part. Applying machine learning algorithm to training, to prepared examples. Evaluation, because in practice, you are going to build many models for a single task. And during evaluation, you will choose the best one. Deployment in machine learning is all about application of chosen model for prediction using new data. Okay? So we have 20 minutes more or less, plus some time for questions. Let's do it. Let's try again. Business understanding. RMS Titanic was a British passenger liner that sank in the North Atlantic Oceans in the early hours on April 15, 1912, after colliding with an iceberg during her maiden voyage from Southampton to New York. It was like that. So, at 11:40 p.m., Lookout spotted an iceberg immediately ahead of Titanic and alerted bridge. It was too late. The starboard side of Titanic struck the iceberg, creating a series of holes below watermark. 5 of the ship's watertight compartments were breached, and it soon became clear that it's doomed, as she could not survive more than 4 compartments being flooded. Titanic was ill-prepared for such an emergency. The crew had not been trained in carrying on evacuation. Third-class passengers were largely left to fend for themselves, causing many of them become trapped below decks when the ship was filled with water. Women and children first protocol was generally followed when loading the lifeboats. But Titanic only had enough lifeboats for about half of the passengers on board. So that's the problem statement. Now we can look at the data and we can understand those variables. Okay? So to describe variable, you can start with descriptive statistics. But they can lie. Statistics are simplifications and can be tricky. When in doubt, look at your data. And you should be looking for missing data values, errors, outliers, distributions, and correlations. So it can be done, actually. And with this insight, we can prepare the data, but this time we will prepare the data. That's the huge difference. So, any questions? Good. So, data understanding. Then was data preparation. And, can be tough. Feature engineering is process of transforming raw data into features, which better represents the underlying problem. We already understand the problem. So they better understand the underlying problem to machine learning algorithm. As a result, the model accuracy on unseen data will be higher. Okay? So it's data preparation. And it's said that, right now, it's said that 80% of any analytical project time and budget is eaten up by data preparation tasks. 20 years ago, they said 60%. So it's getting worse. Why do you think why? And it's actually pretty universal across the whole world. Any problem and any company, the statement is always the same. 80% plus is data preparation tasks. What's going on? Sure, we are dealing with big data. That's one reason, good one.
Model development becomes quicker and simpler.
So could also be like this, yes. But recently, like yesterday even, there was a machine learning conference in Prague, quite huge. Over 10,000 attendees from 40 countries, including both Koreas, were there. And different things were discussed, from natural language to image processing on high scale. And what they were saying constantly, again and again. So, for natural language processing, to get a good results, those results I'm showing you right now, we hired a bunch of writers. They write those stories because the data, collected data from Twitter was not good enough. For image processing, they are saying, we hired a bunch of graphical designers because just a satellite photo was not good enough. There was no learning there. So the bottom line is that still, it may change, but still, right now, better data wins with cleverer or smarter algorithms. Okay? And we know this, so the focus is switched. So, or the amount of task, yeah, is accordingly applied. So what I did, you will get this link. So I dealt with those outliers by scaling some variables. I imputed missing data in different smart ways. I corrected some errors in those variables and generalized some variables. Finally, all features were encoded as numerical. Because the learning function I'm going to use, so we are close to answer to your question, so the learning function I'm going to use requires it. Okay? So now you can see that there is a passenger ID. It was like 900 people almost in this training data set. The majority died. 3 classes of passengers, 2 genders. It was a long time ago. And stuff like this, you can see. So, we have prepared data. But you go too far and use or add too many features. So feature extraction or feature selection are 2 ways to reduce dimensionality, hence simplify the model and avoid overfitting. And this should be easy. Features, input variables are numerical. Label, output variable is categorical. What's the correct way to assess the correlation between them? What can I do to measure how strongly this feature or that feature is correlated with my label?
There are several ways. You have filter and wrapper methods, and filter methods are thresholding, and wrapper methods use the target algorithm to assess on the part of data.
True. But it's even simpler here. But thank you very much. So let's start simple, with the simplest approach, how to measure the correlation. Because that's the starting point, yeah? Then we can, so linear correlation?
We need to measure the influence for the accuracy when we delete one of the...
Yes, that's something we already heard. That's very good, and we are actually using this. So it's the assessment post fact. We are building different models, model trained on different set of features, and with this we can assess the true usefulness of any feature. But it's very costly process. Yes, let's use simple statistics. ANOVA, exactly. So that's ANOVA test here. Thank you.
One quick, we're trying to record this session, so if you have any questions, if you can raise your hand, I will try to run as fast as possible, and then I give microphone. Otherwise, questions will not be recorded. So.
Okay, I will try to repeat this.
Or you can try to repeat, you can try to change it. So raise your hand, I will get where you are. Thank you.
So right now we know that there is even a simpler method to assess the usefulness of those features. Let's use statistics. In this case, ANOVA. So based on p-values, I selected the best, the most strongly correlated features. Yeah. And as you can see, the class, the value is pretty small. Sex, also pretty small. Age, let's say, is still lower than 0.05, yeah? Let's use it. Sibling spouses, no, it's a garbage, it's a noise. Parent-children, as well. But there is a family size. Add that feature. This one, sibling spouses plus those parent-children, equals to family size. Family size is even worse. Okay? But then this family size was converted into binary variable. Is alone. Was this passenger alone or not? And, surprise, surprise, it's very useful. Feature engineering. Okay? Good. So now we have prepared data, selected features, and it's time to build a model. And I will start with this slide and then answer your original question. So hyperparameters tuning. Parameters that define a model architecture are called hyperparameters. Thus, the process of searching for the ideal model architecture is referred to as hyperparameter tuning. And those hyperparameters can address model designing questions such as, how many trees should I grow in my forest? Or what's the minimum number of examples required at leaf level? Or what fraction of randomly selected features should I use for each tree? And there are many of those hyperparameters. Okay? Some algorithms are pretty complex, like neural nets. Artificial neural nets requires a very, very precisely tuned set of hyperparameters. Otherwise, they will not work. They also requires a lot of data. So probably they are not the best. Neural net is not the best for this example, where we have only 1,000 training examples, okay? And we are just start playing with machine learning, and we are not sure about what optimization method should I use and why this lambda value should be like that. So I choose a gradient boosting machine. Gradient boosting machine is a predecessor of extreme gradient boosting algorithm. Maybe you have heard about it. Those Kaggle players probably did, because extreme gradient boosting is a winner of a lot of those contents there, okay? But still, there is no the best learning algorithm. You have to understand your problem, you have to understand your data, and based on those two things, you can select some algorithm you think will be good enough for this specific task. My recommendation is start with gradient boosting machine or extreme gradient boosting, because they are easy to tune and you will get good results quickly. Okay? So here I generated like 5,000, almost 5,000 different set of hyperparameters values. Hopefully you still can read SQL. Useful things to know. So I just generated all those values and then used them to call this build model store procedure in a loop. Okay? But now we have lots of models, even more than you can imagine, probably, and we still, so we have to choose the best one. Probably assessing or checking the accuracy on trained data is not good. We already did it and failed miserably. But we have limited amount of data. And as it's always the case that there is not enough data to train our models, removing part of it for validation is problematic. So k-fold cross-validation works by dividing training data into k-folds, subsets. Then the holdout method is repeated k times, in such that each time k minus 1 folds are used for training and 1 fold is left for validation. And the error is measured by averaged all those k trials, and that we got this accuracy. But you can see that I'm using trained data, yeah, but prepared, but it was split here into 10 folds, 9 folds used for training, 1 fold used for validation. Okay. What do you think? What we achieved? Because right now it looks like that. As I said, about 5,000 different set of hyperparameters, which means k was 10, 50,000 different ensemble models were trained. Yeah? Okay, the results are here. That's accuracy. It doesn't change a lot because it happens that I know this gradient boosting machine and this data sets pretty good, and I selected the correct range of those hyperparameters from the very beginning. So if you will be playing with this, you will get results from, I don't know, 75% up to whatever. Okay? Now, it's time to retrieve the best model, and I use the simplest from the most accurate models. Because you know already, simpler is better. Use it for prediction on test data, submit, and what do you think? Who thinks that the true accuracy measured by Kaggle is over 80%? 1, 2. So what? Anybody else? What are you thinking? It's better, worse? Okay, I will show you. So now it's 82, 0.82. Not that bad, but we didn't win. What can we do? Remember, more data is always also better. Can we use more data for training?
We can deploy data from other catastrophes in the history.
That's nice way of thinking. Feature engineering at scale. Let's find more useful data. That's true. But so I'm totally with you. Well, or even the check weather data, whatever. The family history of whatever we can find. That's why the data is so valuable right now. But let's find the more simple solution.
Data augmentation.
We already did it.
Try a different model.
I'm pretty sure that this one is good one. I need more data. What I did here, I split it into 10 folds. And how many folds were used for training? 9.
So you leave one out.
Or, simpler even, train this best model on all data.
And use Bootstrap to validate.
I already validated. I know, its accuracy is here. I'm assuming that the statistic holds, yeah, for this k equals 10. So I know it. So now I tried the model, this model, one of those, on the whole training data sets, on all training examples, and to conclude, who thinks we won by doing this? Just you. Thank you. Another disappointment. It's better, so everything is as should be. We are in 190 something, yeah? But we didn't win. Because for this competition, the top, actually not only for this, the top of the leaderboard is occupied by perfect models. Models 100% accurate, which is suspicious. Still, we didn't cheat, build good model, use it, and maybe even learn something on the way. So that's the link I promised. You can check this GitHub repository. New examples are coming as I'm writing new chapters. That's my contact details, so please stay in touch with me. And first, thank you, and then we will have time for questions. So thank you.
Okay, let's try with 3 questions to start.
You were saying about controlled machine learning. What do you think about uncontrolled machine learning? Why yes, why not?
Yes. Right now, the majority of practical application of machine learning are supervised tasks, which means the data was labeled as here. Unsupervised techniques are used for clustering, anomaly detection, compression, encoding. What else? Generating new fancy pictures as well. But it's a small percent of practical usage right now. For the same task, if I use clustering or any other unsupervised method, I will get worse result. That's the bottom line.
Thanks.
Okay. Yeah, 2 more questions. So maybe my question.
Yes.
So do you think it's possible that people just found a data set elsewhere on internet and cheated?
So if I got you correctly, you were asking how they cheat.
Yeah. What's the way to cheat Kaggle and win?
Are we recording this?
Yes, of course.
In this case, actually it's easy because the data is available even on Wikipedia, yeah? So you can get the whole list, also the test part with the answer. So you don't have to build a model. You have to copy-paste from Wikipedia to get 100% accuracy. But there are different ways as well. For example, by submitting a lot of results, you are misusing, by doing this, you are misusing test data as validation data. So there is a threshold, but there is a lot of people who are trying this, yeah?
Actually, one question about this. Would it be possible?
One second.
Theoretically, for us cheating, would it be possible to actually use this validation data on their side as a training data and overfeed it to the point that it will actually learn only this encoding?
Yes, you are absolutely right. By doing this, you will win.
Yeah, but other question I asked before, how can we know exactly which models are in those libraries, and is there some documentation on it? I'm sure there is, but where to get it?
Yes. So, if you are going to use this Microsoft Machine Learning Server, there are 3 libraries for R and Python, and they are all well documented, even on website, or mostly on website, Microsoft website. So, I think I'm connected, so give me a sec, and that will be the good sum up. So that was R, and hopefully it's more or less good file loading. Oh yeah. So where we are like here. This one. Copy, paste here, search, and there is documentation. Yeah. Maybe a link to website at the end. Okay? So it's always like this. Or you can wait for a book.
Okay, so so I guess the more questions will be after next presentation in the w kuluarach. Once again, thank you, Marcin, for the talk. Please give Marcin a warm hand again. Thank you.